Close the door again last time.
See what?
In case there's an active shooter, I have to close the door.
Did you say again?
No, not again.
Just gotta put up a mat problem. Put a mat problem with the window. No.
Oops. Okay. So 3.3 is a product rule. So basically, if you have a product of two functions and you're taking derivative of the entire thing, this is what happens. So you're gonna have, basically you take the derivative of the first one and you multiply by the first function, or the second function, plus the derivative of the second function times the first. So it's really easy to remember if you think of it just derivative first times second plus derivative second times first. So this is, and it doesn't matter what order, just make sure that you do one derivative and the other derivative separately, right? You can, after doing this quite a few times, you'll see the pattern, you'll remember. Okay. Number two, this is the one that I always forget which one, because I always forget the order. Since it's minus, it does matter which one comes first. So if you have two functions being divided, right? And of course, g cannot be 0, which we'll make a note of that in a moment. So this will equal the derivative, or sorry, the g function squared. And on top you have g times f prime minus f times g prime. Okay, so just, oh, quick note here. G cannot be 0. Right? So I put these on a formula sheet because you're going to need them for test 2. Probably all the following tests. Guess that's it. We'll save the chain rule for next section. Let's start doing some examples. So the entire homework section is just take a derivative over and over again using the basic rules from 3.2. So I'm hoping you remember the rules we talked about, or you did 3.2. That way this will be a little easier to follow. And if not, well, let's see how it goes. This is example 1. Let me open your homework, make sure it's the same problems. Three point three. Okay, last few look like annoying. Let's get rid of those. That looks semi-interesting. Keep it there. There's 2 of them. That's just weird. Okay, let's start with problem 1, I guess. Some basics. So questions about finding tangent lines, all that stuff is all still in play. None of that has changed, right? Remember we said use a derivative to find a slope. Once you have the slope, you can find the equation of the line that goes through that point if they give you a point. So all that is the same crap. So the only difference is the derivatives are harder to find, but everything means the same. F prime still means the rate of change function. Nothing has changed. Does that make sense? Same ideas, same concepts, different approach to find the derivative. Okay. So problem 1, find, to keep it short, find the derivative. That's all we are doing over and over again. So g of x is equal to x squared plus 3 times x squared minus 8x. Now, there's 2 ways to write the notation. I don't know if I mentioned this last time. I wanted to, but I might have forgotten. Note before we start. G prime of x means derivative of g. d dx of g. Shoot, forgot to switch. Thanks. So if that's g, g prime means derivative of g. Okay. If you see this notation, d dx, it's the same thing as g prime, but this is a little more specific. This is actually a preferred notation. Like when you get higher into mathematics, this makes more sense. But when we're first learning the derivative, the quote is a little easier to manage. So I'll probably use a prime most of the time in this class. So, but I need you to know what this means. So d dx of g means the derivative of g with respect to x, meaning I'm taking derivatives with respect to the x variables. Of course, we're only doing in this class derivatives of one variable, but when you get to calculus 3, you'll be doing 3-dimensional derivatives and integrals. So some variables become constant, some are actually considered to be a variable depending on what derivative we're taking with respect to. But again, that's way later. Don't worry about any of that. But this is important, the notation. D of g respect to x. I'm hoping you've made time to watch the videos that have the theory in there. I haven't been mentioning that much theory, but just in case. That's what the theory means, or the notation. Anyway, so let's do the derivative.
I should say respect to x again.
Yes. I'm going to change something minor. I hope that's cool with you. To make this make more sense to you, I'm going to rename this y of x. You'll see why in just a moment. This is just a side note, because I remembered some of you may not have seen the videos. Okay, so the derivative of y with respect to x, or in other words, y prime, is equal to, right? Let's find the derivative is what I'm saying. If I label this f and I label this g, we can just straight up find the stuff I need separately and just plug it in. So like over here on the side, I'm going to do this down here just to make space. I labeled that to be f. I labeled this guy to be G. So what is G prime? What is the derivative of F and derivative G? Would be two what?
Zero.
Well, this will be 0 for sure, right? But this guy will be 2x, right? You bring the 2 down, you subtract 1 from the power. So it got reduced by 1 power, 1 degree. So that's all 3.2 stuff. Do it again over here. Derivative of this guy. Make some space. Be again 2x, and this will become just a constant. So if you do the derivative on the side, we can then apply the product rule because we have a product of two functions as my y function, right? So yeah, we have this guy and that guy. Now, technically, you couldn't FOIL all that garbage out and take a derivative term by term like you did in 3.2, like we did last week, just doing power rules. But if these functions get ridiculous, you're going to have to do it this way. So this is really a shortcut because I can put a 10th power on this guy and you're not going to FOIL that out, right? No way. So that's where we're going to use this. So let's do it. So I found all the derivatives. You guys have any questions on these? I know this is, I don't know if you've gone to 3.2 yet, but that's where these came from. You guys cool with these derivatives? Okay. So formula says F prime G, right? So F prime G plus G prime F. There's a derivative using the product rule formula. Now we should probably multiply it out and combine like terms. I believe that's what they did. Let's check. They have the same numbers? Yeah, cool. Yeah, they multiplied it all out. So let's do it. So 2x cubed minus 16x squared. Distribute that guy here. FOIL or multiply that out, however you want to think about it. That'll be 2x cubed plus 6x minus 8x squared minus 24. Combine all like terms and we'll be done. So 2 and 2 for the cube. Negative 16 minus 8, it's negative 24x squared. It's only one x, regular x, 24. Okay, any questions on the algebra, the side derivatives, or the main derivative? We're just following a formula, but the formula requires you to be able to do the power rules from 3.2 and 3.1 we talked about. Yes, go ahead. All right. Let's do, I also give you the formulas for cosine, sine, and e to the x, right? So let's do stuff with that garbage in it. Oh, number 2 has stuff. Check this out. So it's a product of 3 to the x times cosine. So you have an f and a g. So I'm renaming it y just so we can label those f and g. That's the only reason. That's how the formula was written, so let's keep it that way to make it so it makes sense in our head. Let's do it. You guys cool on this page? There's no rush.
So what you were saying was that like in the very beginning.
Mhm.
When they go FX, or like those original equations, that's just so we don't have to put it into the x minus h squared.
Right.
for h.
Yeah, so that method works for anything.
So that could have worked, that's what we're talking about. If we put that in, I would say.
Yeah, if you would have used, you would plug this as your f, all this at the same time. Then you have minus f, fx plus h minus f, so it would be super huge.
And that's what you're saying, is that that would just.
Yeah, you want to do the shortcuts and the formulas because that becomes more and more challenging. But you will have to do it only once on the test. But I want all of them to be more like power rule, product, quotient, those formula types. Example 2, problem 2. Find the derivative. So we'll call it y. So y of x is equal to 3e to the x times, what was it, cosine?
Yeah, cosine.
So find the derivative, find dy dx, or if you prefer, find y prime. So y prime will equal, I'm going to do the derivatives over here. And I'm going to label this guy as my f and g, two different functions. So f is 3e to the x. G is cosine. Oh, let me make space there, sorry. I did it last time. So what is the derivative of 3ex? What was the rule? Yeah, it stays the same, right? What is derivative of cosine? Minus sine x. Okay. So plug them in. So the formula is f prime g, right? 3ex times g plus g prime f. So this is f prime g, g prime f. So we're just using a formula, nothing crazy. Any questions on this? Okay, I'm gonna move on to the quotient rule then. Problem 4. Find the derivatives y of x equal to 3 sine x over e to the x. So you have a quotient. We will start the same. I'll call this F and this guy G. So find dy dx. So same thing over here. What's derivative of 3 sine?
Cosine.
3 cosine. And e stays the same, right? Derivative of e to the x is e to the x. Okay. So the derivative on the formula page, first thing we wrote down, right? Quotient rule. It says g squared on the bottom, right? So you take g and square it. So g is always the one on the bottom. That's what g is referring to in the formula, the denominator. Okay, on top it says what? G f prime. So G f prime minus f g prime. Okay. So that will be on top. You could technically factor ex, right? You see that? So I factor it out. So I'll have 3. Also pull out the 3, I guess. So I have cosine minus sine. E squared is technically e to the 2x, but I'm not going to do that because it's going to cancel with one of them up here, right? So now I have 3 times this garbage over e. I think that is as pretty as it's going to get. Is there any questions on what we did? So just keep in mind that they may ask for a slope of a tangent line after you define this derivative, right? We get to the very end. All right, what's the slope at x equals to 5? You'll plug in the 5 in there. That makes sense? It's going to be the same stuff. You just plug in a number and you'll find a slope at that number. But you'd have to plug it into this guy. So the final answer, the derivative, is just this guy. Okay. That's cool on number 3.
I looked down when we were writing, so you said that on some of those, like if I checked into the line, they might give us a number to plug in, and we plug it in all the places that we see X.
Yeah, exactly. So if they said find the slope at x equals to 2, you just plug in 2 everywhere. And then punch in your calculator, whatever number you get, that's the slope.
So that would be like number 5, right? Where it says C equals 0.
I believe so. Let's see. Yes, so you first find the derivative, so very similar to what we just did, and then you plug in the c, and that's what you get here. They use exact numbers, so they're using a unit circle. That's all they did. If you punch into your calculator, you'll get a approximation. Yes.
I'm sorry, so for the second example here, what's the actual answer?
This guy.
The actual final answer. Sorry,
This is right here. So fine. That's your derivative.
that whole thing?
Yes.
Oh, okay. I got one more something.
I mean, we could factor, I guess, but that's all you can really do at this point. I mean, we could pull out this guy.
How's the homework one?
I think either way is fine. But you technically have two terms. It might have this as negative 3ex in front of the sign, but it's the same thing. Let's see how they wrote it. I'm pretty sure it's the same thing. Yeah, they factor the 3, but you don't have to do it that way. If you would have left it as two terms with the 3ex in front, that would have also been correct.
Thanks.
Let's go ahead and let's do 5, I guess, so you can see the slope thing. You guys cool on this page? Before we move on to 5. So example 4. Was it 4? Let me remember where. Yeah. You said problem 5, right?
Yes, sir.
Find the derivative, then find the slope of the tangent line at C.
The F of C. C prime is what it's saying.
Yeah, they don't say any of that, but that's what it means, right? That derivative, the value, the implicit derivative is giving you a slope. So if we're given a function, what rule should we use here? It's going to be product, right? Because we have a product. Okay, so I'm going to rename it to Y because I want to call this F and G just to remain consistent. Not that it matters. So this is my F and my G. So F is this guy. What is the derivative?
So 2x squared minus 2. Minus 1, or 2x2 plus 1.
This one for F?
Plus 2.
So remember, we gotta bring that 3 down, right?
2x squared plus 2.
It's close. Yeah, it's an x cubed. So you gotta bring down the 3 and then subtract 1, right? That's the power rule. So we should have 3x squared for the derivative of the x cubed. Derivative of 2x makes the x disappear. And we showed that because it becomes a 0 power. So we showed last time. So what is this first term going to be here?
sorry, 25.
25 plus derivative of 4x, right? And then this is 0. So dy dx or y prime will be derivative of the first times the second. I don't think I have space. I'm going to move it down. It's right too small. Sorry. Derivative f prime, derivative f will be 3x squared plus 2 times g, so 5x to the 5th plus 4x minus 5 plus g prime times f. So far, you guys still with me? So that's technically the derivative that they asked for. It's just not multiplied out, right? We did the calculus step. All that step is algebra, and then we can do that slope part. But does the derivatives make sense?
Yes.
Okay, so let's see if they actually multiplied it. Sometimes they say it's cool to leave it factored. Looks like on this one, they were fine with it. So if you want to be lazy, you could try typing it in like this first. And if it give you if you get mad about it, multiply it out. We should multiply it out because we know how to do algebra, but this just looks nasty. So I wouldn't blame you if you didn't. But anyway, they also want to know the slope at C, right? Luckily it's 0. That's easy to plug in, right? So the derivative at 0 will be 3 times 0 plus 2 times 5 times 0 plus 4 times 0. Already has space. Plus 25 times 0 plus 4. Times 0 plus 0. We're out of space, so I'm not going to put the powers. You agree that this will just be simply 0 plus 0, right? Which means this is just 0. Which means it's going to 0 this out. So we're going to get 2 times negative 5 plus 0. So the slope at 0 is actually negative 10.
25 times 0 plus 4 would be, oh, but it's times 0. Never mind. Hang on.
Yeah. 4 times 0. So what we found was the slope of the tangent line or the instantaneous rate of change at that point. All those concepts are in the background.
That's the M tangent slope.
Yeah, the slope of the tangent line. Also, it is also the instantaneous rate at that point. So if this was like velocity, it'd be the instantaneous velocity of your position function at 0. Anyway, any questions on this problem? It's very formulaic, right? There's a lot of theory in the background. So don't forget. See that guy. Yes. 7. Oh, sure. We'll do 7. So find f prime and f prime at c. C is 0. F is cosine x over ex. Now, again, I'm going to rename these guys because we're used to f and g. You don't have to. But it will make more sense when you read this later.
That's sweet.
This is the hard one for you. Derivative of g is e of x. F prime is going to be what?
Negative sign.
Negative sine. Okay. So the derivative squares the bottom. So we got e x squared. Then we have, what was the formula again? What's the first part?
Is that F prime times
F prime g. Or gf prime, same thing, right? Same thing. Put that in the center. Minus, what's the next part? G prime times the F. Okay, we're done with the derivative. So that will be, if we factor a negative, they're both negative, right? Negative e to the x will be factored, and we'll be left with sine plus cosine over ex squared, which will become negative sine plus cosine over ex. Now they want us to plug in 0, right? If you plug in 0, you will get sine 0 plus negative cosine 0 over e to the 0. What is e to the 0? Yeah, anything to the 0 is always 1, right? Sine 0, you guys remember? Yeah. Yeah, 0 plus 1. Let me fix that. Right. So the answer will be negative 1.
That's 0 plus 1 over 1.
There's a negative in front. So negative we factored.
Make sure because it looks good. It looks like you just messed something up.
Yeah, that's yours. The bottom one?
Yeah.
It does, right? Any questions on 5? Okay, so that concept makes sense, right? If you ask for a slope, you find the derivative using whatever method is appropriate. Then you plug in the number. Is that clear? So think back to 3,1 and 3,2. When we found the equation of the tangent line, we first found that slope using a derivative, right? Then we would use the point and that point slope formula to find the equation of the tangent line. So all that we did last section is can still be done here, as long as it gives you a function and a point. So it's the same thing.
Took this all the way until we got to plug it in 0.
So this is the derivative here. This is the slope of the tangent line. So if I were to, if they gave us a point, which I guess they did, right? If they would have told us find the equation of the tangent line, you would use this slope. Then you'd plug in 0 into here and use that as your point, and then use a point slope form like we did last class. Because they have to give you an x or a y. If they only give you an x, you have to find the y yourself, which can be done easily, right? You just plug in the number. And so we don't have to rehash the same thing. I guess we could do it here just for fun, real quick, just to remind you. Page 7 continue. Were you guys cool on that page? Okay. Let's say 7 continue and make up a question. Find the tangent line, or the equation of the tangent line. What was F? Sine or cosine? Yeah. And F prime was plus cosine, or just? Okay. So this is what we found earlier. So this is part 2. So we're going to redo what we talked about last time with more difficult problems. So it's the same thing. The only thing that changed was finding F prime was more annoying. Last time it was easier, right? Same stuff though. Same. We plugged in the 0 and we found it to be -1, right? This is slope of the tangent. So we said last time. M tan. So that's what I'm going to call it. Now I told you to use this equation to find the equation of the tangent line. So plug in the point. Now they did not give us the 1, but do you see that if I plug in 0 here, I would get 1? What's cosine of 0? E to the 0 is also 1, right? 1/1. So I didn't show that part, but I believe you can plug in 0. So let's use this point. 0 will be the x and the y will be 1. M tangent we found to be -1. So the tangent line will be this guy. You see how we can still ask those questions, right? So this, you might have a couple that pop up and they'll say, you know what, do this quotient rule first and then tell me the tangent line, or tell me the slope. So, does that make sense? Okay, last thing I want to mention for this section is first, second, and third derivatives. Like, what does that mean? Before we move on, is there any questions on this example.
Plug in the zero to get that one, that part was to be able to plug it into the,
To the
to
line,
get the Y value for the point solution.
yeah, we need the y value to find the line equation.
What if it says that I'll use a closed rule?
You have to use a rule from 3.1, the long one, with the limit.
Delta, right, or something like that.
I think the book might use delta.
Delta.
They delete some of these. So no way. Let's do 15 and we'll move on. So this will be doing the power rules. So the stuff you saw last time. Find f prime and f double prime. Basically, you just do one derivative, you get that answer. You do another derivative of that result. So first derivative would be, using the power rules, you bring down the 4, subtract 1, bring down the 3, subtract 1, bring down the 2, subtract 1, minus 2. Yeah, that would just be the minus 2. This gives you 4x cubed plus 6x squared minus 14x minus 2. So now to do another derivative, you use this result and do it again. So I'm showing the steps for the power rule since that's all we're doing here. Might as well show it. 4 times 3, subtract 1. 6 times 2, subtract 1. 14. Oops. Yeah, we're good. So as you can see, you can keep going, but eventually it'll disappear, right? Power functions have a finite number of derivatives. Transcendental functions don't. And a theoretical smooth function has infinite number of derivatives, like each of the x would be considered a smooth type. So if you read a math book for fun, like late at night, read about smooth functions. So that's all that means.
Yeah, that would is number 15 on the-
Might be a different number on. I haven't hit saves because I've been deleting questions. So yours might have a different number. It's in there. It's might be a different number. Yeah, hit refresh. So that was the product and quotient rules. So quotient is the one that's annoying. Take your time on those, because that sign will mess you up. And then when you start dividing, you may have to reduce stuff. That happens. A chain rule. That was a confusing one, because it requires you to understand composite functions. You guys remember composite functions? That whole f of g, the fog, remember that? College algebra?
Oh, like running terms?
Yeah, you would like put a function inside another function.
Oh, yeah.
That f of g, whatever. Might have. My days all blend together. I don't know what we did. Okay, let's delete these hard ones for you. 1 second. Okay. Now it looks so wrong. That might help us learn. Okay. I'm assuming you haven't seen the theory, the videos that has a theory on it. So let me at least mention the formula. So these derivatives, the chain rule derivative is required when you have functions within functions. So that composite function requires a special rule. Okay, so I'm going to define, so let f and g, let me first title this section. Yeah. What's the name of this? I think it's the chain. So this is the chain rule. So suppose f and g are differentiable. And y is equal to f of g of x. So it's a composite function. The derivative of y, or dy dx if you prefer, will be this. It'll be the derivative of the outside without messing with the inside times the derivative of the inside. That's the shortcut, the rule. And if you have function within a function within a function, you'll just be multiplying times each derivative, working your way, how do I phrase this? Visualize it. 3 of them, work your way in. We're not there yet. Working your way in. Yeah, okay. So it gets really weird when you have like 3 or 4 parts, which you're probably not going to see. At least you're not going to see 4 or 5 in this class, but you might one day somewhere else. So remember, you're working your way the innermost function. Okay. Here you'll see for sure at least 3. Not that often. So let's pick a simple one. Work our way up to some nonsense. Given y equal to f of g, that is to say, y is equal to 3x minus 7 squared. Right? I use the Latin shortcut right for it, that is to say. So this, I mean this. It est. So in the homework, the way it's going to start. Share screen garbage machine. What they're trying to get you to do here is to identify what is the inner function, what is the outer function. Do you see? So the inner one, the g, is a 3x minus 7. So this function, think back to college algebra, this function is multiplies an input times 3, right? Then subtract 7. The outer function squares any input, okay? So the g function is going to be the 3x minus 7. They call it u in this homework, but who cares? I'm using this notation because it makes a little more sense when we do the derivatives. The f function is a squared function, right? So I made this note just so you know what they're talking about in the homework. F of g, just to remind you of college algebra, this means f of 3x minus 7, which means this guy, right? Does that make more sense? Do you remember? Composites, right? I can separate them into 2 separate functions, and I can compose them together to get back to where I started, right? Same thing. We're not doing anything yet. I'm just trying to remind you what composites mean and make sure you're able to identify the 2 separate ones. That's all we're doing. F of g, g and f together. So let's look at the homework problem again. Complete the table. Y is equal to f of g. They want to know what is the g, what is the outer function f. So they call it a u squared. Who cares? I used x. Anyway, that's what number 1, 2, 3, 4 are wanting. They want you to identify what's the inner and what's the outer, because you need to know which one is which in order to use the formula. The formula requires you take the derivative outside without messing with the inside, then you multiply by the derivative of the inside. Okay. you don't know what is in and out, then you can't do it. So let's try to do it with this guy. So the derivative of y. Let's go and do it this one right here. So you guys agree that the outer is the squared function, right? That part's clear? So f, what is the derivative of x squared? 2x, right? So you bring down the 2, but our x is really this. Then you subtract 1, right? Then you multiply by the derivative of the inside function. The inside is this guy, right? What is the derivative of 3x minus 7? Yeah. So the derivative of y will simply be 6 times this garbage. This rule has is a little nuance, so it's a little longer to understand than the others, but it's not too crazy. It just might take a minute for it to sink in. It requires that composite stuff. Any questions on this?
I'm sorry, so I missed where x minus 7 went. Okay. Where that 3 is.
Take the outer root. That's the outer root. Now that's the inside. Then you multiply by g prime, the inside that. Here. Root of this is 3. Root of 7 is 0. Root of 3x is 3.
Okay.
Let's do some more. Any other questions on number 1?
What was that one?
This is number 1. They didn't ask us to do the derivative, they just asked you to identify outer and inner. I did the derivative just so we can do it just for fun. Okay, let's do number 5. I'm going to rename it y again. Find y prime, or dy dx if you prefer. So I'm going to write this guy down real quick, then we'll switch over. Okay. So what is the outer function?
2x squared, 2x to the 5th,
Yeah. What is the inner function?
5 minus 7x.
Okay. So if I find a derivative, I do the derivative of the outer part first without messing with the inside. So you bring down the 5, right? Just like we've always done. And then I subtract 1, right? So we're basically pretending it's a 2x to the 5th. Does that make sense? Then you multiply by the derivative of the inner function. What is the inner function?
Write it with the X in front or we have to write it with the X in front?
What do you mean x in front? This
Well, I
one?
mean, I guess it would matter. I mean, come on, it's
Yeah, it doesn't matter.
7, -7.
That's a quote. So that will become 10. 5 minus 7x to the 4th times -7. You guys see the pattern? So the answer will be -70 times 5 minus 7x to the 4th. So we're just using this formula here. Derivative of the outside times derivative of the inside. Okay. This is the derivative of the outside times derivative of the inside. Simplify. Any questions on 2? So, just so you're aware that power, quotient, product, all those rules are still in play while you're doing the chain rule. So you could, while you're doing derivative of the outside or inside, you may have to do a quotient rule or a product rule. So you can see how this becomes more and more gross, right? But so this section will require you to be really good at the last few methods. Since we've just talked about them, I understand that it's not, you haven't had a chance to do them yet, so they may seem more difficult. But keep in mind, I wouldn't do this section until you got the power rule and product and quotient down comfortably. Okay. You guys cool on 2? Let's see, this one looks funky. Let's do 8. I guess. What number was this? Oh, this was 5. Let's do problem 8. So y is the cube root of 6x squared plus 7. What is the outer function?
To the 1/3 power.
There's going to be the cube root. The whole radical outside is the outer function, and then the inner is what's inside. Okay. So the derivative. So we want to make a note. Say, you know what, f is a cube root function, and g is this inside stuff. One of my professors used to hate when we would write f of x, because technically that is an input. You would say f of x is an input, not the name of the function. So he was very nitpicky. He said it should be called f. So I was like, technically it should be just written as f. F of x implies that it's a specific point. But he was very, very particular. But he was but he was right. If you read like high-level functional books, functional analysis books, that's how it's supposed to be. But in college algebra, calculus, we don't write it that way because it's hard enough without getting too specific. But he had some cool classes though. He taught us the mathematics behind MRI machines, how it works, the imaging. It was really, really cool. The whole imaging process of an MRI is basically just the FEM method to solve various differential equations when it receives the data. So it's able to approximate what the image will be, which is really high-level theoretical math. This was really, really fun, but oh man, it was disgusting math.
What class was this?
It was, sorry, I'm a little tired now. It was a class on the finite element method, which is a method to solve differential equations or partial differentials. And all that means is just equation full of complex derivatives. And those derivatives are real life things that happen in nature that you're modeling. So when you solve these things, you find out what's actually happening. So solving them is difficult. So after a while, we can't use very many methods. We have to use hello computer software to figure it out. But when you solve them, you get stuff like images or MRI stuff. You do all kinds of neat things. You can also figure out the impulses of semiconductors and all kinds of neat things. So if you go far into physics or engineering, you'll see that a lot of the things you're trying to work on turn into a high-level math problem, complex math problem. Anyway, so the outer function, we should probably rewrite this first. Sorry, I was thinking about that old man. Because now it's more obvious, right? So, what would you do first? No, not yet. I want to rewrite the original first before we do it. So you see how a cube root is the same as a 1/3 power, right?
So this would be the 1/6 x squared plus 7. To the third.
Oh, it's just the power. Treat it like any other power. Don't treat it any different. So if it was a square, what would you do? Yeah, you put it in front. So same thing, right? Bring the third down. So when we do it, yeah, we got to subtract the fraction by 1, which will give us a negative 2/3. Right? So at that point, it will go at the bottom because it becomes a negative power. But treat it like you would any other power. It is still a power rule.
I skipped a step. My bad.
It's okay.
This is where I meant put it.
Oh, I see. All right, and then multiply by the derivative of the inside. What's the derivative of the inside? Yeah, 12x. Right? So at this point, we start simplifying. We're going to bring down the 2/3 because it's negative. That 1/3 will be at the bottom as a 3 because it's already at the bottom, right? 12x will stay on top. So this is what's going to happen. 12x multiplies on top. This 3 stays down there. This guy moves down and becomes positive. You guys have any questions on the algebra step to here? You see what happened? Yeah, so you agree that the 12x is on top, right? Negative means it's going to be moved down. But when this comes downward, the 1/3 was always on the bottom. So another way to think about it, in between stuff, you could say this is 1/3 times 1 over this guy times this. Make sense, you said?
Yeah, I got that part.
Oh, okay.
There's more than 2/3 that messed me up.
Oh, the 2/3. I see. What is 1/3 minus 1? Yeah, so we're still doing the rule here. We should show it. It's supposed to be 1/3 minus 1. Any questions on number 3 or example 3?
Is that there?
Yeah, that's the answer. Let's check.
Yeah, it's turning into like 4x over
Yeah, that's true. You could do that.
x to the 9.
Yeah, you can reduce the 4s. Yeah, both are fine. Do you see why it's steep though? Or why it looks like that? Or no?
Reduce the rules of
Yeah, it's just the rules of exponents, right? That 12 should cancel technically. I would leave it this way because it's good enough to me. Check out 11. It looks kind of like product rule, right? You have a function times a function. So that should be a hint that you should use the product rule. But then you see that one of the functions is a little complicated. You have a square root of 9 minus x squared. So that one is a composite function. So you're going to do the product rule, but while you're doing it, a chain rule will be required. So we're going to do what we did in basically all previous sections at the same time. 3, 1, 3, 2, 3, 3 in this problem. For the most part. Except quotient, I guess. We're not doing that one. Got it. Assuming you guys already took your test, right? I don't remember anymore. When was it closing? I'll be sure to start grading that soon then. So y prime is a product rule. I'm going to call this f and my g. So the formula is f prime g plus g prime f, right? So that means take the derivative of x squared and then multiply by g plus the derivative of g times f. This time I didn't do them on the side like before. I'm using the quote to tell you, the derivative must be done here and there. So what's the derivative of x squared?
2x.
2x. Cool. Derivative of this guy though is a chain rule. So it's not straightforward. So I'm gonna work in here in these giant brackets. I'm gonna show an extra step before we do it. Take derivative. So the derivative of the outside, right, means you're gonna bring that half down, subtract by 1, and then multiply by the derivative of the inside, right? So that'll give us 1/2 times 9 minus x squared, 1/2 minus 1. All this is happening inside, times the derivative of the inside. I'm going to show an extra step. So it's all happening inside the brackets. Brackets are not necessary, but it's emphasizing what we're focused on at the moment. Okay, so what's the derivative of this guy? The 9's going to go away, right? And then this guy, yeah, it's negative 2x, that's right. So we will have 1/2 times 9 minus x squared to the negative half times negative 2x. And then the x squared is out here chilling, just waiting for you. At this
Where do we
point,
get that second,
which one?
that second 9 times x squared.
It's the derivative of the inside function, right? Part of the chain rule formula. It's f prime, f, the outside function, times g prime. So this is saying take the derivative of the inside. So I wrote it again.
If you go one more up,
Mhm.
that one more line up, yeah, like on that one, we're taking
Derivative of this.
that, which is the one right above it. The one right above it.
Yeah, so this means derivative of this guy, or which is the same as derivative of this guy. Then we begin the derivative here, which requires you to take the derivative of the inside, which is then done there.
Oh, that's right.
And then now we just do algebra.
That was the inside.
So I try to show more steps so you can see what's happening little by little. Is there any steps before we go any further? Do you see the calculus steps? At this point, that's the derivative. We're technically done, right? But got to do a bunch of algebra. Got to polish it. So you see there's a product rule that requires a chain rule. Is that part clear? Is it clear that we did a product rule, and during the product rule, a chain rule was required? You see that part?
That's the 9 minus x squared, right?
Yeah, so we did the product rule a bunch of times in the last section. But while we were doing G prime here, it required a chain rule, which is all this garbage.
That's how you got the extra 9 minus x squared.
Yes. So essentially we're doing notice that, what is this derivative? Take the 1/2 down. Subtract 1. Multiply by the inside. That's all we are doing. And that's what we did earlier. That's what this section is all about. That's happening during the particles. Same stuff from last section. Okay.
And out of curiosity, why did there have to be a chain?
Because we have a function within a function. You have an outer and an inner. As soon as you see a function that looks like that, you have to.
So the square root is its own function by itself.
Your square root function, and then you have that weird parabola inside.
The scroll that shows how it was different from the one above, but we didn't have to use it. But maybe it's
This guy. This one. So this is just one function that required a chain rule, right? You see how we had to do the inner, right? So we did it the same way. It's just that this one had an extra step. You had to do the product rule.
because the x squared was in front.
Yeah, you have two functions being multiplied. So there was more work to be done. Just like we said in 3.3, you have two functions being multiplied, you apply the product rule. F prime G plus G prime F. G prime required a chain rule, and that's why it got all weird. Okay, so you need to be comfortable with all rules because it can all pop up at the exact same time. You could easily see in your homework something that makes you do product, chain rules, quotient rules, power rules all at the same time in one question. It'd be an ugly question, but that is a possibility. Yeah. As long as you guys understand it up to here. You guys good? Okay. So you have a half and a -2. That's cool. This is the negative power. So that's going to go on the bottom, right? So we actually have negative x over 9 minus x squared. To the 1/2, forgot the half. Move to the bottom and make it positive so I can write that better. And it looks the same, but anyway, multiply the x squared and we will get might as well just make it minus because it is negative. Minus x cubed over the square root of this stuff. That's pretty much your answer. That would be cool. We stopping there.
Really dumb question. Where did the negative x come from?
This one? That's this x.
Okay, gotcha.
And this went down. The 2's canceled. Stayed negative on top.
I forgot about that.
Now we could add fractions. We could rationalize. But This is fine. But you can see how they can get kind of messy pretty quick, right? Like this 13 one looks like garbage. Say we do that one. You guys cool on 4? So it's gonna be similar.
Expect all of our answers for this section to should look like trash.
What's that?
Should we expect all of our answers for this section to look like trash?
Yeah, pretty much.
It's a serious question.
Yeah, expect them to be, yeah, ugly.
Maybe fold pages of paper.
Pretty much.
Not this trying to be so long to look at the most simplified answer as the correct answer.
Well, you can go keep going if you want to polish it some more. Polish that turd, man.
You like that? Some denominator, that square root of 9 minus x squared.
Yeah. Yeah, we could technically get the same denominator, add them together, multiply stuff out, might cancel some terms.
Put that first one over 1 and cross multiply.
Yeah. Because when you get the same denominator, this square root would cancel, which would then introduce a 2x, which would then combine with that top part. It could be slightly prettier, but I don't really care.
On the homework, do you have the capability of how some questions say read it, some say watch it? Do you have the capability of changing it?
I don't think I
Watch it?
can for all of them. I think some just don't exist. But I can check to see if I can turn some more on, but last time I checked, it was only for like certain problems. Let's do some more trash. 13. You see how that's a chain rule, right? Because you have a function inside of a function right away. That part is clear, correct? You have a square outside, and then you have this weird fraction inside. That's 2 functions. The inside function, though, is a quotient. So when you're doing it, you're going to have to do a quotient rule for the inside. Is that clear? I'm going to use X because my T's look like crap, man. Oh, we got a time, right? What's the date? Monday.
21st.
Sorry. Yeah, sorry guys. We went over time. Not bad. We're just having so much fun, right? I just lost track of time.
This one
It's the
is
most
negative
nuts
5
thing I've ever heard.